Hello and welcome to today's session. My name is Mamta Jha. I'm working as a Senior Developer Advocate with DigitalOcean. Let's see what is today's agenda. So we would understand the components of a Kubernetes cluster. We will see through the architecture of Kubernetes cluster. We would understand what exactly a master node means, what exactly a worker node means, and the processes of Kubernetes running in the cluster. Once we have got a brief idea about what exactly is a cluster, we would go and provision a managed Kubernetes cluster in DigitalOcean and understand what is the benefit of having a managed Kubernetes service as well. Once my cluster is up and running, I need to do administrative tasks on it. I need to run application containers on it. So I would configure a local machine that is like my personal laptop or a remote management server to manage my Kubernetes cluster. I would configure it so that it can talk to my Kubernetes cluster. And we would also discuss how do we configure our Kubernetes cluster, how do we enable scaling of our worker nodes. So there is a concept called as node pool. We'll discuss about that. And at the end of today's session, we would run a sample application in our Kubernetes cluster, which we would have spin up. So to start with, a basic overview of Kubernetes cluster architecture we would do. But before to that, let's understand why Kubernetes is needed. Because need is the mother of invention. There should be a use case or a problem which we would address with Kubernetes, right? So let's first try and understand what exactly is a container. So container, normally we say as it provides a standard way to package our application's code, its dependencies, its configuration into a single object. And they share the operating system which is installed in the server, and they run as an isolated processes. So let's see, we have a node or a server or a machine over here. You can name it as anything. And obviously, we would be running an operating system on that. That is called as a host operating system because this machine would be referred as host or a node. So this is the operating system running on the node. You install a container runtime like Docker on top of it so that you can spin up containers. So we would be installing Docker on top of our operating system, and then we can spin up containers, and containers would have the applications and would also have the libraries, dependencies, environment variables, everything captured inside this particular container itself. And you can run several other containers in the same machine in an isolated fashion so that they don't interfere with each other. So this is how container setup looks like. It provides us a quick, reliable, and consistent way of deploying our application, and it is not dependent on the environment on which it is being built. It can run in any environment. It is not environment dependent. It is agnostic of the environment in which it is prepared. So this is our application A, and the other one is our application B. Container 1 and container 2 can talk. So we were happy running containers in a single host or machine. Where is the place, or what was the need of Kubernetes to come into picture? I could run a container, but I couldn't automate the lifecycle management of a container using a container runtime like Docker. I couldn't scale up in an automated fashion using a container runtime like Docker. And even when we were moving or scaling up to a multiple hosts, I would not live with a single machine running thousands of containers in my production environment. Rather, I would have multiple nodes running multiple containers inside that. So when container 1 of node 1 wants to communicate with container 1 of node 2, that is not possible with plain Docker container runtimes. That is when the need of Kubernetes came into picture. And Kubernetes is an open source container orchestration system for automating our application deployment, scaling, management, everything. It was originally designed by Google, and now it is maintained by CNCF, that is Cloud Native Computing, foundation. In today's session, we would first look at the architecture at a high level, and then we would drill down into each of these components. We would understand what advantage do we get with a managed Kubernetes services like DOKS of DigitalOcean as well. So Kubernetes is helping us to host application containers in an automated way, and it helps us manage them better and also helps us to enable communication between them. There are different types of nodes in a cluster. Here, which is depicted in green color, is the master node, and the blue ones are the worker nodes. So master nodes work is to control, to monitor, to schedule and manage all application containers, and worker nodes work is to host those application containers on them. So let's start with dissecting more of the processes of our Kubernetes master node. So to start with, we would see what does the API server provide. API server is the primary management component of Kubernetes. It is responsible for orchestrating all the operations within the cluster. This API server exposes the APIs so that from the external world, the users like us can perform management operations on the cluster, and even the controllers of our Kubernetes cluster talk via the API server. So API server is providing us APIs to perform the operations on the cluster. Next comes the scheduler. I have given a container definition and I am saying that spin up an Nginx server for me. API server receives that input, but next what? Someone should decide where this particular container would spin up, because I have an option to spin up in different nodes altogether, right? I have several worker nodes. I'm not living with a one worker node. So scheduler is the component which identifies the best fit node to host the container based on the container definition which we have provided. Once container is up and running, we should have the complete configuration of our cluster backed up somewhere, and that is etcd. Etcd is like a complete configuration map of our cluster. It maintains a key value mapping of what is running where in the cluster. And then comes the controller manager. We would be dealing with controller manager. There are different types of controller manager like replication controller, deployment, daemon set, stateful set. There are many more like that. We would be dealing with each one of them in our upcoming webinar series. So now let's focus on the rest of the components in the cluster apart from the controller manager for today's session. So we understand the three components sitting inside the Kubernetes master: the API server, the scheduler, and the etcd. So API server receives the request, scheduler takes up the request, finds the best fit node, and spins a container on the worker node which it has decided as a best fit node. But in the worker node, someone has to receive the request from the master node, and that is the Kubernetes agent sitting and running on the worker nodes. So kubelet is the Kubernetes agent which is sitting on the worker nodes, taking all the requests from the API server. The other component running on the Kubernetes worker node is the kube proxy. It helps us enabling the communication across all the application containers, and cAdvisor is the monitoring component sitting over there. It takes all the metrics from the containers, from the node level, from the pod level, and provides when we need it. We would be using that cAdvisor component when we would be doing scaling and all that. So this is how the Kubernetes architecture look like. And let's see how do we provision a Kubernetes cluster, which is a managed Kubernetes cluster in DigitalOcean. So this is how the Kubernetes console would look like. So let's go directly to the Kubernetes DigitalOcean's console to spin up a Kubernetes cluster. So I go to cloud.digitalocean.com. I log in with my credentials and I am in my DigitalOcean console. And if you go and see on the left hand side, there are different services listed out here. You select Kubernetes and you would go to the Managed Kubernetes service page. Here it says Kubernetes can be spin up in minutes. It is very cost effective. It is ready to use, and you would have up and running cluster within minutes. So what advantages does DigitalOcean Managed Kubernetes services provide? It will simplify our getting started with Kubernetes. It will spin up the machines. It will install Kubernetes automatically to that. Tomorrow, if you want to upgrade from one version of Kubernetes to the other, it can do that for you. It is easier and faster to deploy any managed workload, container workloads on that as well. So let's go ahead and spin up a Kubernetes cluster. So you hit on creating a Kubernetes cluster. Here there are some options which you need to select. You need to provide some parameters so that our Kubernetes cluster is up and running. First of all, you have to select the version of Kubernetes which you would be choosing to run in this particular cluster. I'm going with the latest version. You can go back to few older versions as well. And then you have to choose the location in which you would run your Kubernetes cluster. For example, I'm choosing a Singapore data center region. I'll live with the default networking at this point of time. And here comes the capacity of my cluster, the definition of my cluster capacity. So let's see what exactly a node pool means. So my cluster would have worker nodes, but worker nodes can be consolidated together. A similar configuration worker node are consolidated together or grouped together in something called as node pool. So what is a node pool? A node pool would be a group of nodes in the cluster which have the same configuration. And when we create this cluster, the number and the type of the nodes in the node pool can be defined, and we can have multiple node pools with different node configurations as well. So let's see, how do I define this? I'll name this node pool as node pool 1. I live with standard type of nodes in this particular node pool. I would be increasing little bit the size of the machines. I'm living with 2 virtual CPUs and 4 GB RAM as the machine hardware specifications, and I want to spin up 2 nodes of this type belonging to node pool 1. You can even add more node pools. Let me add a node pool 2 now, and I would be taking up CPU optimized type of nodes in this, and I would take up 4 GB RAM, 4 virtual CPUs with 8 GB RAM, and I'll spin up 3 machines of this type. So at this point of time, I'm creating only 2 node pools, one having 2 nodes of standard type and the other pool having 3 nodes of CPU optimized type of nodes. And here you get the rate. You're getting how much you would spend in case you are spinning up, you're running these machines, all the 5 machines for the complete month. You can even enable metric server, a monitoring system on this particular cluster so that you can monitor your cluster. It's like an add-on. You can do that now, or you can do at some later point of time as well. I am enabling at this point of time itself. I would tag my cluster something like webinar 1, and I can choose the name of the cluster. I can say K8S, and I can say webinar 01 maybe. And here you have to choose a project wherein this cluster would belong to. So I'm living with, I would choose the webinar project. And then you hit on the create cluster command, and it would take around 10 to 12 minutes to bring up the complete cluster. So in the background, it would actually spin up droplets. That is a virtual machine in DigitalOcean world. And it would, we have chosen 5 worker nodes. That means 5 droplets would be coming up. They would have Kubernetes in it. They would have Docker component in it. And Kubernetes, what would be running? Kubeproxy would be running. Kubelet would be running. CAdvisor would be running. And few of the DNS servers services would be running in that droplets, and you would have Docker technology or the containerization technology also up and running, because you have to, end of the day, spin containers on that, right? So it would This particular cluster creation would take 10 to 12 minutes, bringing up all the 5 droplets, installing Kubernetes software in that. And then once it is up and running, we will see how we need to communicate to this cluster from our local machine. So once your cluster is up and running, you can follow the instruction in the same screen itself, and it would help us configure our local machine to communicate to our Kubernetes cluster. So let's click on Get Started. We would have to install 2 different command line interface tools. One is for the Kubernetes cluster, which is called as kubectl, and other is to talk to the DigitalOcean APIs. So for that, we would have to install DOCTL. So when we install these 2 on our local machine, we can configure our Kubernetes cluster configurations, and we would start talking to our Kubernetes cluster from our local machine itself. So I have installed both these tools in my machine at this point of time. It's pretty easy. These are step-by-step instructions. You can follow them. After installing those command line interface tools, you need to download your configuration file of your cluster. So I would go ahead and download the configuration file. This is the configuration file which has got downloaded in this particular local machine. And here it gives the command to configure your local machine to talk to your Kubernetes cluster using the configuration file which you have downloaded. So let's go ahead and copy the Kubernetes file to .kube folder. If you see here, it says .kube folder. So let's cd to tilde.kube. That is my home directory, and in that home directory I have .kube folder. I already had so many clusters running, and I have placed their configuration file in the same location. So let me copy. I think A8S webinar 01 was the, yeah. So this is the configuration file. Let me copy to this present directory. I have copied. Let's see whether it is copied. Awesome, it is copied. And after that, now I have several Kubernetes configuration file. How does my DigitalOcean understand that which Kubernetes cluster I'm talking at this point of time? Suppose I want to spin up a container. In which cluster do I spin up? And there is when DOCTL comes into picture. In this, you would say DOCTL Kubernetes, you would say Kubernetes cluster, and you are saying kubeconfig. So you are saying this is the kube configuration, save at this point of time, and whatever I run next, that should run in this particular cluster. So this is my cluster setting, and it says it has set. Let me clear the screen and let me go ahead and execute the command to list the nodes in my cluster. So kubectl is the command line interface, and I'm saying get nodes. If you remember correctly, we had spin up 2 nodes in pool 1 and 3 nodes in pool 2, and all the 5 nodes are shown up here in our local workstation console as we are interacting with our Kubernetes cluster. So let's go back to our cluster. I'm skipping this, it's done, and let's go back and see the node configuration in this cluster and see what all we can do with the node configuration. I can go ahead and add more pools as well. Suppose I want to add some general purpose nodes, and that would be just a single node I want to add, and I want to add 2 virtual CPU nodes. I can do that. I'm adding a new node pool with a single node to my present cluster. This I'm doing once my cluster is up and running. These are the administrative tasks which a cluster administrator would do when he wants to increase the cluster configuration or the size of the cluster. What else can I do? I can even go and resize my particular nodes in my cluster. I can say no. In pool number 1, I don't want to live with two nodes. Let me live with one node. I can do that. Let me decrease the size. Sorry. Yep. So if I'm increasing the number of nodes, I can update the number of node counts as well. And you want to delete the nodes, you can delete the nodes from here. You can edit the tags of your node from here. You can do a lot of actions from here itself. Let me see, resizing. Yeah, resizing, that time the update count was not showing blue. So I want to increase to 3 nodes. So at this point of time, I would have 7 nodes in the cluster. I've increased pool 1 with one more node, and I have added pool 3 with one more node as well. So these are actually droplets which are running in this cluster, right? So let's go and see pool 1, 1 node, 2 nodes, and these are pool 2 nodes. Pool 3 node is coming up running, and it would also add pool 1's third node as well. So let's go back to our cluster and try and do kubectl get nodes. These are the nodes which are ready, so it's listing them. So this is what we can do with our node configuration changes. We can change our cluster resizing and all, the nodes resizing and all we can do. And this is how we configure the local workstation to talk to our Kubernetes cluster as well. So now my cluster is up and running. Let's run a sample application, a pod of Nginx, and see what commands do we need for that. So kubectl, to execute, we say run. I'm saying generate. Let's say I want to generate a pod. This version, we would be talking about the different versions when we really write the template file of each of the resources. I want to spin up a pod which is named Nginx. I want to spin up with the image of Nginx, and I want to run only a single replica of that. So let's see what happens as soon as you run this command. Because containers are very quick to spin up, you can go ahead and list down the pods which are running. So there is an Nginx pod which is up and running. kubectl get all would get you all the resources which is been in this particular cluster. So here Nginx pod is up and running. You can see there is a default service of Kubernetes which is up and running. So I won't be able to reach this particular container from outside at this point of time because I have not configured networking for it. I'm just showing you in this particular section how to spin up a container. And containers are called as pods. So let's see what exactly a container and a pod means like. So in Kubernetes world, we talk the smallest deployable or creatable, deletable unit as pod. It can be one or more application containers that are tightly coupled. That means, for example, at this point of time, I'm just running an Nginx container in my pod. So my pod is equivalent to a single container at this point of time. But for example, just imagine my container application is not intelligent enough to push the logs by itself to a external volume which is attached, right? So I would run a standby or a helping application like Splunk, which would pull the application logs and push it to the external drive. So for that, I would place application Nginx along with application Splunk together each time in a pod. So container 1 is running Nginx, container 2 is running Splunk, but they are sitting together in a single pod. And that is when we are saying that they are tightly coupled. Splunk doesn't have any work if it is not sitting with Nginx, right? And Nginx is not self-sufficient to do all its logging activities without Splunk. So they are tightly coupled, they are dependent on each other. And when containers sit in the same pod, they share the same IP address, but they listen on different port numbers. You can configure the port numbers on which each of the container applications would be listening to. So today we discussed about the Kubernetes cluster, the architecture of our Kubernetes cluster, what is a managed Kubernetes service looking like, and we have spin up a cluster with 7 nodes. We saw what different node pools are. We saw how we can add new node pool, delete older node pool, or delete a node from a node pool, resize, all those things we saw. So let's see what plan and pricing that DigitalOcean provide. So we charge you only for the number of worker nodes. So remember, because it is a managed Kubernetes cluster, a master node is up and running, which is managing all your worker nodes, but DigitalOcean doesn't charge for that. It just charges on the number of worker nodes you're up and running. So no additional charges for the master node. There is no restriction of which region you are selecting, but your cluster can't span across region. I chose Singapore region. My cluster would be up and running in Singapore region. All my 7 nodes are placed in Singapore region. It can't span across different regions. And you can have maximum of 512 nodes in a cluster at this point of time. And maximum number of pods which you can have on a node is 110 pods. So this is exactly what we saw today. I showed you a demo as well. So here now in this particular cluster, we have 7 nodes up and running. You can go back and verify the number of nodes as well. So let's go and see the number of nodes. It would have brought up pool number 3 as well. So if you see 3 nodes, here 3 nodes, and in this pool you have 1 node. So you have 7 nodes in this particular cluster. You can have little bit insights on this cluster as well. It would list you the details of all the specifications, how much is the CPU usage, what is the load average, and what is the memory usage, the disk usage. All those things can be seen over here, and you can see few of the things on the overview page itself. It shows you the total cluster cost. It was $240 when I was running with 5 nodes. I've changed the number of nodes in the cluster, and it is costing me a little bit more now because now I'm running 7 nodes in the cluster. You can change the cluster tag at any point of time in case you have missed your configuration file, or you are setting up a new workstation. You want to download the configuration file. You can download the configuration file, the kubectl command line interface, and the docstl command line interface. Run and execute the docstl Kubernetes cluster configuration command so that you can talk to your Kubernetes cluster without specifying your configuration file name. So this is what we have in today's session. For the next session, we would have many more things. We would be spinning up different types of controllers. We would be talking about storage, networking, scheduling, and many more things. So this is from today's session. Hope you guys have liked today's session. I will open the stage for Q&A now. Thank you.